All right, let's start. So today we are going to talk about relationship between classes. Relationship between classes, and in particular, there are two types of relationship that we are going to discuss: is uh, aggregation and composition. Uh, so that's today. Now, in the previous discussion before, we only create one class. So we create fraction number class, we create hour class or time class before, and these classes are not really related to each other. Okay. Now, in reality, commonly classes relate to each other, or in other words, objects can relate to each other. For example, student object can relate to courses object. So a student enroll to courses, or courses has students, and so on. Okay, so in reality, classes relate to each other, and therefore, in our application, we need to uh, be able to relate a class with another class. Okay, now that's what we aim to discuss today: how to represent relationship between classes in our coding in C#. But maybe not coding yet. First, we're going to talk about design of relationship between classes. Now, relationship is called association. Okay, relationship is called association. Simply, association means relationship. And there are many associations. There is a binary association, which is relationship between two classes. And there's also n-ary association, is relationship between two classes. In this unit, we only going to focus on binary association. In specific, as I mentioned, we are going to discuss about aggregation and composition. Okay, let's start. Now, as shown in this tree, aggregation and compositions are types of association. In aggregation and composition, object of one class owns object of another class. So it's the owner-own relationship. What's the difference between aggregation and composition? Aggregation first. So we use aggregation if the relationship between classes is not strong. In other words, the relationship between the owner and the owned object is not strong. So in this aggregation implies to relationship where the child owner can independently exist without the existence of the parent. Okay, so assume if class A has an aggregation relationship to class B, it means class A uses class B, or class A owns class B. In aggregation, the lifetime of object B, the child, does not depend on the lifetime on the object class A, the parent. Even if the object class A is deleted, the object class B is not necessarily need to be deleted. For example, let's say class A is objects or subjects in Ubaya. For example, OOP. Okay, class A is object OOP subjects. Class A is OOP subjects, and class B is student sub objects. Okay, student objects. That includes Kathleen, Agis, and Kenneth. Okay, so OOP object has 3 students: Kathleen, Agis, and Kenneth. Okay, so in this case, it is aggregation. Why? Because the existence of OOP, sorry, not OOP, the students, each student, Kathleen, Agis, and Kenneth, is not dependent to the existence of OOP subject. Even if OOP subject is deleted, even if OOP subject is deleted, okay, each student that belongs to OOP should not be deleted automatically because that student can enroll to another unit, another subject. Okay, so that's why it is aggregation. So object student can exist even if the parent is deleted. That's aggregation. There will be more samples on this, so don't worry. This is another example. In a transportation system, bus has driver. A bus is the owner of the driver. So a bus has driver. If a bus, even if a bus is deleted, the object driver can still exist. Again, similar to the subject and students relationship, the driver can still exist because the driver can drive another bus, for example. Another example is in a human resource system, the department has employee. The department, for example, IT department can have many employees. Even if the department is removed or deleted, the employee can still exist. Sales system, sales order has customer. Sales order is the owner of a customer. Even if a sales order is deleted, that customer can still exist because that customer can still be recorded in another sales order. Make sense? That's aggregation. Welcome, Kenneth. You good?
Yes, sir. I picked a wrong link. I picked the Monday link, so
Well, that
I don't know
happens.
why it's not started.
And
Yeah, I'm
you
fine.
wonder why you're alone?
No, I wonder why it's not start yet.
Okay. All right, good. All right,
Yeah.
welcome. So next, that was aggregation. And this time, we talk about composition. Now, if aggregation signify weak relationship, on the other end, composition signifies strong relationship. What does it mean, strong relationship? It means the relationship between the parent and the child or the owner and the own object is strong. It means the child cannot exist before the parent exists. And if the parent is deleted, then there is no need for this child to exist, and therefore this child is automatically deleted. Okay, assume class A has a relationship with class B. It means A use class B, and if A is removed, the parent is removed, then the child should be removed. The existence of the class B depends on the existence of class A, the parent. Okay, for example, in the housekeeping system, a house has rooms. A house has rooms. House owns rooms, and room don't exist separate to a house, obviously, right? And if the house is removed, then the room should be removed too. It cannot exist without a house. Okay. Course has topic. A course has topic. A topic is not relevant without a course, and therefore when a course is deleted, the topic should also be deleted. And a user management system, say user has login history, and this login doesn't mean anything if the user is removed. So when a user is removed, the login should be removed too, and that's automatically. What is another example? A simpler example. Let's say let's say, a staff and its dependents. So, for example, for a lecturer is recorded who is the spouse of that lecturer, who is the kids of that lecturer. Okay, those dependents object is heavily depends on the parent object, which is the lecturer. If the lecturer is removed, then all spouse or kids data will be automatically removed. That's composition. So it's contrast to the aggregation. Okay. Now, for example, quick question. Okay, let's start from Catherine. In a movie review system, there are two objects, movie and review. The relationship is movie has review, or in other words, movie is the owner of a review. Should this be an aggregation or composition relationship?
Composition.
Good, because review cannot exist without the movie. If the movie is removed, the review should also be removed. Good. Agis, you there? Agis?
Yes, sir.
Okay. All right. The second one, academic system. Class has teacher. In other words, class is the owner of a teacher. Is this composition or aggregation?
I think it's aggregation.
Good. This one is aggregation because teacher can still exist even before a class, even if the class is removed. Cannot. The third one, marketplace system. A seller has product. Seller is the owner of a product. Should this be aggregation or composition?
A composition.
Yes, because well, yes or no, depends. If it's like a product that is custom to that seller, for example, the seller is selling food, okay, is selling food, and therefore the food is specific to that seller, then yes. But if the product is a common product like Coca-Cola, right? Every seller can sell Coca-Cola, right? It's the same product. In that sense, it can be an aggregation, but it can also be composition depending on the case.
Also, it's depend on the product, sir.
It depends on the requirement, and the requirement is depends on the case. And in this case, the product needs to be clarified what kind of product sold by sellers.
Okay, sir.
All right. Catherine again. Song player, album has track. You know album?
Yes.
Okay. So for this one, album is the owner of track. Should this be aggregation or composition?
I think composition.
Correct. Because the track is part like inseparably from an album. Last one, I guess, game application, player has weapon, player is the owner of a weapon.
Composition.
Yes or no, depends on the weapon. If, for example, we're talking about a hero with its specific weapon, then yes, it's composition because that specific weapon cannot be owned by other classes, for example, right?
Yeah.
But if the weapon is actually something that can be traded, for example, then it can be an aggregation. Again, sometimes it depends. Okay, so therefore in design, the relationship between classes, we need to describe, okay, what's the case in here that is needed to justify whether it should be an aggregation or composition. But overall, good. You have a good understanding on when it should be aggregation and when it should be composition. Good. Now let's talk about a bigger case. Okay, this is a case of publisher and magazine. A publishing system application records publishers, magazines, and articles data. The relationship between these three objects, so the objects are publishers, magazines, and articles. The relationships between these three are one publisher can publish 0 or many magazines. One magazine can be published by one publisher. One magazine has one or several articles. One article can be published in one magazine only. Okay, so these are the relationships. User can access the publisher of a magazine, but still can access the publisher data and magazine data directly. So access is another characteristic that distinguish the aggregation and composition. In aggregation, where the relationship is weak, where the existence between the parent, the existence of child is not related to the existence of the parent, the child is accessible without accessing the parents. Okay, we, for example, can know the details of students without knowing the details of the course a student is enrolled to, right? We don't need to look at the course and get the students to get the user name, for example. We can just access the user object directly. However, for example, in a movie review, we cannot find or access a review without accessing the movie. First, we find the movie, for example, Batman Begins, and then we look at the review owned by that Batman Begins object. We cannot just go to the review without accessing the parent. Okay, so that's another way to decide whether it should be aggregation or composition. User can only access article data by searching its magazine first. Okay, this is the requirement. If the system use OOP approach to record the information, then we obviously need the following classes. First, publisher. Second, magazine. And last one is article. Now, as I promised, we will have more discussion on aggregation and composition. When should we use aggregation? We should use aggregation when object A that we use in class A, the owner, doesn't have a strong relationship with class A. Repeating again, if we delete the parent, the child should not be deleted automatically. And in here, we add another characteristic. The child object can be accessed independently regardless to the owner without accessing the owner. On the other hand, for composition, the child object can only be accessed through the owner or the parent. Okay, and therefore we need to access the parent before we can access the hang on. Next, in this example, imagine. So before I continue, let me explain what this means. So this black diamond over here, this signifies composition. In other words, strong relationship. This means the magazine is the parent, and the publisher is the child. To read this, magazine is the owner of the class. Magazine has publisher. Now, if we put it like this, it means if a magazine is removed, then the publisher will be removed automatically. Does it make sense? No, obviously, because publisher can publish many magazines. The removal of a magazine should not automatically remove the publisher. Okay, and in terms of accessibility, since it is composition and magazine is the only owner of publisher, we cannot directly access the publisher data without accessing the magazine. We cannot get the publisher name, for example, without knowing the magazine object, the magazine owner. It also doesn't make sense. And therefore, based on these answers, based on this analysis, this solution, this design is incorrect or wrong. Solution 2. What if we switch side? It is still composition, but this time publisher is the owner of magazine. Okay, in here, based on the relationship, if a publisher is removed, then all magazine data should also be removed or deleted. It makes sense because think about it. A magazine only belongs to a publisher based on these requirements, right? One magazine can be published by one publisher only. So if the publisher is removed, we can safely remove the magazine. However, based on the accessibility in composition, we cannot access the child directly. Now, we can ask, can we access the magazine without accessing the publisher? Okay, and this is can be yes, can be no, depending on the requirement. So the system requirements did not really tell about this one. So this is can be yes, can be no. Based on that one, this solution can be correct, can be correct. However, because in this system, we can directly access a magazine without accessing the publisher, we will not use this model later. So this is accepted. This is okay. In a design, there can be multiple solutions that equally correct. We just need to decide which one to use. Now, another solution is to use aggregation. If a publisher has aggregation relationship, it means if we delete a publisher, okay, then a magazine still exists. This does not really make sense because then it will confusing whether, okay, so a magazine can have no publisher because it's been removed, so it's confusing. However, in terms of accessibility, it makes sense because both publisher and magazine can be accessed independently. Okay, we can directly access the magazine and we can access the publisher independently. But because the existence is having problem, is no on here, it doesn't make sense to have magazine without, without a publisher. So this solution is incorrect. Another important, another acceptable solution is this one. Magazine has publisher, but in a weak relationship. So magazine has publisher as aggregation. In terms of existence, both can exist, okay, independently. Yes. If we remove a magazine, then magazine, the publisher can still exist. However, if a publisher is removed, then the magazine cannot select that publisher. Okay. And also accessibility is also okay. And because in here, we can directly access both magazine and publisher. We will use this model later in our coding. Okay. Now, how about relationship between magazine and article? Previously, it's between magazine and publisher. In here, magazine is said to have a composition relationship with articles. In a sense, article can only exist or belongs to a magazine and can only exist if the magazine, the parent magazine, is still exists. If the parent magazine is removed, then the article charts should be removed too. In terms of accessibility, an article cannot be accessed without accessing the magazine. And therefore, the answer to this are both yes, and therefore the solution is correct, and we will use this model later. Okay. There may be other possible relationship, okay, for this one, for example, but for this discussion, we will use this one. So what happened in real life in design? Well, we need to specify the case when we design this one, so that we can remember, or we can understand the background of each design decision. Now, next, how to draw. Okay, can we use pen and pencil? Yes, you can, but it's too hard, right? Why use pen and pencil? Just use there are tools that available out there that we can use. We can even use the C# class diagram. However, the C# that the C# version that we have is incomplete because we are using the educational license. The complete one is the one that we need to pay more, is using the enterprise edition, and we don't really need that much. So I don't think it's a good idea to pay. Let's just use what we have now. However, if you want to have a complete set of notation, we can use UML diagram software such as Lucidchart, Power Designer, whatever. I prefer to use Lucidchart because it's free and online, and we can use immediately. Notation. So for a class, this is the notation. So it's a rounded square with 3 sections. The topmost section is to specify the class name. So this can be the publisher. And the second section is for attributes. So what are the attributes? So for example, a publisher have ID and name. The last one is for operation. Okay, methods. We put it in here. So okay, title, follow with data member, follow with methods. Now, relationship between classes, as we seen before, we use the empty diamond to represent aggregation or weak relationship between objects or between classes, and the filled diamond, like this one, to represent a strong relationship. The arrow shows the direction of access that can be performed. So for example, in here, class A access class B. In other words, class A has class B, or class B belongs to class A. Okay, just remember one direction. Class A has class B. So for example, if the relationship is class A magazine and class B is class publisher, and we have relationship that one publisher has one magazine has one publisher, it means magazine is the parent, the code to write is this one. So inside a class magazine, we will have data member publisher. Okay, so here it is literally means magazine has publisher, and that's it. Easy, right? This is what it means literally. We will talk about the coding next week. Now, we also need to specify the multiplicity. Multiplicity specify how many instances related involved in the relationship. Okay, in UML, the multiplicity is written as follows. This is 0 to 1, 1 to 5, 0 to many. Okay, so the star in here represent many. So this is 0 to many. 0 to 0 means 0. Okay, sometimes people just put in the maximum possible relationship. So this one is the maximum, right? 0 is the minimum, many is the maximum. 0 is the minimum and 0 is the maximum. 1 or 1 is 1 minimum, 1 maximum. This is 1 minimum, this is 5 minimum. Sometimes people can or usually just put in the maximum. So 0 to many is written as many, 0 to 0 written as 0, 5 to 5 written to 5. 1 to 5 is written as 5. Okay? Other than that, usually we just wrote minimum to maximum number. So for example, in our publisher magazine example, one publisher publish 0 or many magazine. So in here, we always start with asking with reading 1. One publisher publish 0 to many magazine. For the other side, we ask this: one magazine is published by one publisher. The end product is combination between two sides. So the end product is here in this one. How to read is the same. One publisher published 0 or many magazine. One magazine is published by one publisher. Okay, that's how we read. So we always start with read 1 on the object. One publisher published 0 to many magazines. One magazine is published by one publisher. Next. This is the final class diagram for publishing system. So how to read this one is the same. One magazine has one or many articles. One article has one magazine. Belongs to one magazine. One article belongs to one and only one magazine. Remember, if it's just one, it means one and only one. If it's different, then we need to put one or many. Okay. Okay. Another case study. This is a case study for, hang on, exercise. No, this is for exercise, and I will explain about this one together, and you guys need to do the other case for exercise by yourself. Okay. Hang on. I'll resume recording. So this is another case study to discuss. You guys there or you left? You guys still there?
Yes, sir, I'm here.
Okay, good. This is student consultation, and in here we want to create an application that involves a university. The university wants to record the data of students in some study programs, and the student consultation record to the academic advisor. The information needed in this system, including the date when the student came to the academic advisor, the current GPA, and the consultation time, the student problem, and so on. The relationship includes a study program can have many students, a student can only register in one study program, a student can have many consultation records, a student's record data can only be referred to as students. Okay, that's a requirement. Next, requirement. User can access the study program of a student. User can access the study program of a student, but still can access the study program independently as well. User can only access the student's consultation records by searching the student data first. All right, let's do this together. Okay, let me put on the, what's called, Lucid chart next to this one. Don't want a wireframe. I'm going to open a new one. Blank document. Oh, come on. Editable document. Okay. Hang on. Let me just remove this one. How to remove this one? Okay, let's just work in here. This is lock. Let me just remove. No thanks. Delete. Delete. Okay. Now I can create a new one. What? Okay. It's okay. Document anyway. Okay. Now I want to add shapes because I don't want to use these shapes. Don't want to use this shape either. Don't want to use flowchart. I want to add shapes. Standard library. Let's just use object oriented. UML. Class diagram. This one. Okay. Use this one, and then we have this one. First thing first. Based on this, what are the objects that we need to have? Anyone? Just name the object first. You can find based on the nouns.
GPA, sir.
No, that's not an object. That's a property.
Oh, student.
Study
Yes.
program.
Good. Student. Okay. Just put in here. Student. Study program. Good.
The
Let me-
consultation.
Yes, yes. Hang on, let me just make it smaller. Hopefully you can still see this. Okay. Study program or just program. Consultation, good. What else? One more thing. Is there one more thing? Yes, there's one more thing. One more object, one more class. Anyone?
Academic advisor.
Yeah, depends. What do you have in mind?
Student problem? No.
Maybe that's not that's probably not a independent object. That's probably property of consultation. Okay, I think.
No.
No.
Wait.
Information needed. Student problem. Okay, we can put it as a problem if you want. Sorry, as an entity. It's fine. Is that Rn or M? It's M. One more thing, come on. One more.
Consultation date.
No, that's obviously a property.
Consultation record data.
That's consultation. The academic advisor. This one. The lecturer who give advice given by the academic advisor, right? We missed that one. So we need academic advisor here, right? Make sense? Now, as a good practice, let's just first specify the data member. Okay, so in here, this is just a text. Just put in whatever you need to put in. Okay, so usually it says like this. So let's see, NRP string. Okay, no default value. Name string. Don't worry about the plus and minus. GPA, for example, double default 0.00. Make sense? That's all you need to worry. For the methods, don't worry about it. Just remove it, make it empty like this, because we're not going to discuss or specify the methods here for now. For program, let's just say we have ID program, integer, we have name like computer science, pharmacy, law, and so on. This is string. Okay. Problem. Just put ID problem, integer, and description, string, or maybe definition, problem, definition. We don't need to put problem. It's part of class problem, so it's obviously the definition of the problem. Consultation. What do we have here? ID consultation, for example. Integer, for example. What? Date or date time, start, time, date time, date, or start and end, right? Start and end. What else? Just make it like that for now. This is the NPK, which is a string. This is a name, and this is a string. Okay, let's just keep it simple so that we can further understand the characteristics of each class that we have here. Any questions so far?
The advisor.
The advice. Where do you think we should put it?
I think the advice and the problem should put into the consultation.
Depends. Can one consultation have many problems? If yes, then it should be separated. If no, where one consultation should only discuss about one problem, then we can put it inside the consultation. Or we can have, yeah, that's how. If one consultation, the requirement is not, hang on, I don't think there's any requirement on that one. Searching, okay. Okay. Right, so yes, I think we can leave it like this, and this is the what advice, like this. So one problem, one advice, one definition, and one advice. Okay. Anything else that we miss here? No? Okay.
Sir,
Yes.
since it said that in the consultation start and end, do we need a date? I mean, like,
Yeah, this is date
oh, it's
time.
already okay. It's already included in date time.
Yes, it's both date and time.
Okay, okay. Thank you, sir.
Okay, let's start relating these classes. Okay, so hang on. Let me just check if we have lines for this. How to draw relationship then? Aggregation. Agis is dropping out.
His Wi-Fi shut off, sir.
Okay, that's fine. I'm recording this one, so that's fine. How to create that diamond relationship? Composition. No. All right. I guess we need to do this manually. So which one related to another? Let's go with student and program. Okay. Which one has which one? Which one is the parent? The student or the program? A student should be able to exist independently without a program, right? If or not. In here, it is said that a student can only register in one study program. A study program can has many students. Okay, so obviously this is there is a relationship between a program and students. A study program can have many students, and a student can only register in one study program. Okay, what do you think?
So the line from program to student, sir?
Yes, there's a line between student and program, but the answer is that the question in here is that which one is the parent, the student or the program?
The program.
It is?
Yeah.
Okay. Now, let's specify in here. Okay, in here, is it composition or aggregation?
I think it's aggregation.
Composition like this? Like this? So if a program is removed, then students should be removed.
Okay.
Doesn't sound right, right? So let's change it. This one. Change the endpoint with this one. Okay, a program has many students. I don't really like it, because if a program has many students, then we will have in a program we will have collection of students. Okay, and I would prefer to have student has program. So I would prefer the other way around. Let's see if I change. The first line direction. I would prefer like this. So a student has program, but it is a weak relationship because even if the parent is removed, a program should still exist. Okay, this is simply because we need to be able to access the student without the program, but that goes with the other way around. And this is simply to avoid what's called having a list. In here, it means because one student only have one program, we don't have to have list in here. And in here, it also doesn't have a list. Okay, so
sir, I have a question. Is it possible if we change the direction, the aggregation change into composition, or the other way around like that?
Yeah, it's fine.
Oh, so it changed into, for example, if we put program as a parent, it become aggregation, and then if we reverse the line, if we change the direction, is it possible if it changes into composition?
Yep, it's okay. Depends on the case. Like
Okay, sir.
in our example before with the publisher and magazines, we changed the composition to aggregation, I believe.
Okay.
And now in here, it's okay. Now in here, we add multiplicities. Where's the multiplicity? I don't think the multiplicity works. Okay, that's fine. We can add multiplicity manually. This one doesn't work. All right, we can just add multiplicity manually. This one, text. One student can have one and many sorry, one and only one program, right? So we put in here one. Oops. Let's duplicate this one. One program has how many students?
Oh, one or many?
Oh, how many? We can just put many.
Is it possible if it's zero, sir?
Yeah, if it's just recently opened.
Okay.
That's the assumption that we can use. All right, so we already represent the first two requirements in here. A study program can has many students. A study program, one study program has many students. One student can only register in one study program. Okay, now let's put this one here so it's easier. The layout is nicer because in here now it's relationship between student and consultation. So now we can use both ways. Should the students has consultation, because in here one student can has many consultation record, and consultation record can only be referred to a students. Using the same logic, I would prefer to have consultation has a student instead of students has many consultations. Make sense? So having said that, let's use this, and in here I want the other end to be, what do you think? Strong or weak? Weak. Because even if the owner, the consultation is removed, okay, we cannot remove the students. Hang on. I believe I read something else with regards to this. User can access the study program of a student, but still can access the program data independently. So this is weak, it's okay. User can only access student consultation by searching the student data first. Okay, this changed everything. It means, what does it mean? User can only access, sorry? Yes, Catherine?
Student is the owner.
Correct. This means we need to reverse it. And also means it is a strong relationship. Right? That's a requirement, so we have to follow it. Okay, now one student can have many consultation. So we just copy and paste this one. Okay, and one consultation belongs to how many students? One student. So in here we put like this. Make sense? Good. Next. There is no further details about other thing. Okay. So, okay. So because there are no other description on the relationship, it is not wrong if, for example, in here, you can just say problem and say advice. And there's no specific requirement on the academic advisor, but if you want to put it, you can just put the academic advisor. Simply because there is no further details on this one. So we can just choose the easiest path, right? Instead of finding that, we have this. Any question? Any question? Okay, if there's no question, I'll give you question. So do this, study case 1 and 2, and I will wait. Do it now so that you don't have to submit anything, and you can have the rest of the weekend free, at least for me, from me. And yeah, I think it's quite easy. You can just put it in one Lucidchart documents like this. So the first one, you put it on top, and for the second, you put it underneath. It's quite straightforward, actually. Oof, careful when you move it, it's not actually moving along. So you need to move it manually like this. And the multiplicity is a mess. Whoops. This belongs here. You belong here. One shouldn't. Many consultation. There you go. All right. Do you want to stay on Zoom, or I'll stand by on Slack as usual? And you send me the results here. What do you reckon? You okay staying online? Anyone? Just 2 case studies. It's quick and easy. Anyone? Do you want to do it now or later? I'll make it easy.
Excuse me, sir.
Yeah. Yes, I guess.
Maybe I will leave the Zoom because my Wi-Fi is down and I don't have enough.
Okay. All right. So I'll create a submission on ULS. Submit your work there by the end of the day. Okay, it's quite easy. I want you to finish and have a good weekend. What do you think?
Yes, sir. That's a good idea.
All right. Good luck, and I'll see you guys. Let me know if you have any problem. Okay.
Thank you, sir.
You're welcome.
Yes, sir.